Good morning, professors, faculty members, and my classmates. I am Vikas Kumar, currently pursuing BTech in Aeronautical Engineering. Today, I will be giving my seminar presentation on the topic of flying car transport system, which is designed under the Dr. S.S. Godara. A flying car is an elementary supercar that is able to run on the road as well as fly above the skies. It is also known as hovercars. Many engineers and individuals are investing their time, effort, and money to build proper working flying cars using different aircraft technology. Most of them are designed to take off and land conventionally on the runway like other aircraft, which was a great achievement. But engineer and developing flying cars with a vision of replacing the road vehicle with flying vehicles. Therefore, now there are many main focus is on VTOL, vertical takeoff and landing, and some companies are very close to success. Next slide is what is flying car transportation system. FCTs different from traditional transportation system by exploiting the underused near ground space. FCTs are capable for exploiting upon current public transportation by increasing the traffic load and accelerating the movement of people and goods, especially in urban areas, while simultaneously reducing traffic and air pollution. Why we should introduce flying car transportation system? Because of their unique properties. Flying car transport system is environment friendly transportation is supported as flying car equipped with power cells and zero direct discharge and emission can be totally achieved. Second point is traffic jam free transportation system by benefiting from underexploited and unlimited near ground space resources. Next point is less ground supporting infrastructure is required. Most FCTs are operated in near ground space and vertical takeoff and landing mode is adopted as the main and popular mode for flying cars. Less competition for space among road users free up more ground level space for people, making cities more comfortable for pedestrian and citizen. Next slide. This is only an overview of main transportation systems. Next slide. In this slide, the organization of the report is given. The rest of this paper is organized as follows. In section 2nd, we present a brief review of the history of development of flying cars. In section 3rd and 4th, we elaborate on the designs of flying cars and FCTs respectively. In section 5th, the challenges of FCTs are discussed and their pros and cons also discussed. And in section 6, the presentation is concluded. Next slide. In section 2nd, the history of flying cars. Point 1. Just a decade and a half after the Wright brothers took off in their airplane over the plain of Kitty Hawks in 1903, other pioneering men began chasing the dream of a flying car. There was even an attempt in 18th century to develop a gliding horse cart, which to great surprise, but it is failed. Here I look back at a few of the flying cars that discussed themselves from the backs. First one is Curtiss autoplane. In 1917, Gillen Curtiss unveiled the first attempt at a flying vehicle. This aluminum autoplane sports 3 wings and a 4-bladed propeller at the back. The autoplane managed a few short hops. Gillen Curtiss, who could be called the father of the flying cars. The second development in this series is aeroplane development by Waldo Waterman in 1937. The aeroplane was a car where the wings could be detached for storage. And the third one car is in this series, Alfian Report Fulton, who was distanced relatively of this steam engine inverter developed the airplane in 1946. Instead of adapting a car for flying, Fulton adapted the plane for the road. Next slide. Here is in section 3, we discuss flying car designs. We discuss the flying cars in terms of following four aspects. Generally there are four kind of takeoff and landing modes for aerial vehicle. The first one is VTOL, vertical takeoff and landing mode. Aerial vehicles can take off and land vertically. Under these modes, no runway are needed for either takeoff or landing, thus giving more choice for potential takeoff and landing sites and more freedom to reach passengers anywhere they wish to go. And the second one is VTHL, vertical takeoff, horizontal landing mode. Aerial vehicle can take off vertically but turns to ground by taxiing along a runway. Thus, runway are necessary for the landing process, but takeoff is not restricted to a runway. Third one is STVL, horizontal takeoff, vertical landing mode. Aerial vehicle take along the runway before takeoff and landing vertical at the destination. Thus, runway are required to take off process, but there is a feasibility for landing process. The next mode is STOL, as horizontal takeoff landing mode. Aerial vehicle require a runway for both takeoff and landing. This mode is most common mode for fixed wing aircraft, and runway or ground supports are always required. Next slide. In this section, we discuss the design of flying car transportation systems. In the following three aspects: path and trajectory planning, the required support facility, which are the key problem encountered in the large-scale operation of flying car transportation system. The first point is path planning, position and navigation. During the flight process, the most important thing for a flying car following are pre-designed path is accurate positioning and navigation. Therefore, achieving precise information on position and navigation is essential. Various methods have been developed to obtain two-dimensional position information of an object, such as global positioning system (GPS) and circular network wireless fidelity, which is Wi-Fi. The second point is support facilities. Similar to traditional ground traffic system, some sports facilities are essential to set up and maintain efficient service of flying cars. Generally, in terms of these different functions are support facilities, can be divided into communication system and TOL side. The first one is communication system. Communication system are crucial for flying car transportation system, which serve as the central nerve system that collect, delivery, switches, and broadcast information between flying car control centers and information service provider. Second point is TOL side. As flying car transport system are able to provide direct point-to-point transportation service, the location and construction of TOL side should enhance the attractiveness and associate ridership for FCTs by providing high quality service and experience to guarantee efficient mobility for all riders within service area, especially in urban areas. Next slide. In these slides, or we say in section 5, we discuss the challenges of flying car transportation system. The first challenge is safety issue. The most important challenge faced by commercial operation of FCTs are safety issues, which arise from various facts such as flying car safety, including passenger protection related to weather condition, system level safety, including collision, optical avoidance, search and rescues, and environmental friendly. The second safety issue is commercial issue. In this subsection, we discuss the commercial issue encountered by flying car transport system in large-scale commercial application. Manufacturing cost. The manufacturing cost of flying car is the principal participle challenge that hinders FCTs from being widely commercialized. Pilot training and hiring. Although autonomous drive techniques has been developed for flying car in self-pointing modes, the cost of hiring and training pilots. And the one of the most challenging issue in FCTs is commercial license application. Commercial license will undoubtedly be necessary for commercialization of flying car transport system. License will be issued not only for the economic authorities of the central government but also for the civil aviation regulation department, such as commercial space transporters license from federal aviation administration of United States and European United Aviation Safety Agency. Uh, the one of the challenges is the ethical issues, because flying car transport system operate in near ground space. There are some potential ethical issues surrounding the TOL and flying behavior of flying cars, such as disturbance of ecosystem, invasion of privacy, and pollution of the environment. And in this environment challenge, this disturbance of ecosystem, because the height of the operating space of flying car transport system normally range from 10 to hundreds of meter height above ground, which is the main living space birds is responsibly and maintain operating of flying cars, which eventually negatively impact birds by disturbing their nest, proving attacks, scattering eggs, interpreting feeding, and mid-air collision. Furthermore, the noise generated by frequent TOL and flying will also impact ground animals. Next slide. In this section, we discuss the pros and cons of flying cars. The first one we discuss pros. Uses regular gasolines. You can fly and drive in one vehicle, avoid highway traffic and congestions. Next point is short communicate time. Point third is live farther away from your job. Some cons of the flying car transport system are FCTs have a limited market. It is expensive. FCTs need pilot license to operate. Need an airport to take off and landing. Next slide. In this section, we conclude the presentation. As we achieve great success in both air and road transportation, we are moving forward in combining both of them, which means flying cars. Many different technologies are used to build a proper working flying car so that it can replace the road transportation. The third point is one of the important technology is vertical takeoff and landing, which is used in flying cars so that we don't need a runway to take off and landing. And the fourth point is some of the companies are very close to success, and some of there are still trying. Next slide. And thank you for listening.